Hi everyone, I'm Konstantina, and in this section we're going to speak about linear classifiers for images. Image classification is a fundamental problem in machine learning and computer vision, where we take an input image and then our system has to predict the correct class for this specific image out of a fixed set of classes. The idea of a linear classifier is to follow a parametric approach. And in this parametric approach, we're going to take our input image and add a new component in our system, and that is the weights W. Then we're going to write this function f, that is taking the input image in the form of pixels, that is the x, as well as the learnable weights W, and the output of that form will give us 10 numbers, and in the case where we have a dataset with 10 categories. And these numbers will be some classification scores for each of the categories that we want our system to recognize. And the higher the score, the higher the probability is that the input belongs to that class. The linear classifier will simply use this function f, that is nothing but a matrix multiplication between the input pixels x and the learnable weights w plus some bias. And if we unpack the dimensions, we have an image of 32 by 32, which is colored, so it has 3 channels, red, green, and blue. So it's 32 by 32 by 3, and we stretch it in a column vector 3072 by 1, which is our input. And now we want to end up with 10 class scores, so our matrix W needs to be 10 by 3072 to get a column vector of 10 by 1. With the 10 class scores. And the bias will be again a column vector 10 by 1 that will be added to the result of W times X. To see an example of mapping an image to class scores, let's say we have an image with 4 pixels and 3 target classes, cat, dog, and sheep, and our weight matrix is going to be 3 by 4 because we have 4 pixels and 3 classes. And we have our input pixels stretched into a column vector, plus the bias that is 3 by 1. If we do know the matrix multiplication and add the bias, we will end up with this output class scores. And as we can see, the highest score is given to class dog. So one could say that this weight matrix can be seen as a template of the image. And by computing this dot product with the input pixels, we basically compute the similarity between this template and our input image. In this case now, we have some training examples, which are images of cars or deer or airplanes or any other class contained in a dataset. And the classifier is trying to find out what makes the cars, for example, different from the other data. So it tries to find a separation line between cars and everything else. And similar to the linear regression, we have a slope, that is the weights, and a shift from the zero, that is the bias. And this separation line is described by the car formula, where we have the car weights, and then we multiply them with any input image and add some bias. And if the output is larger than 0, then this image is categorized as car. And the same happens for the rest of the images. How would we train now such a classifier? So how do we find the weights? And we take the average image for every class, and on a big data set with several classes, the average image looks like this set of images, one for every class. And now, if we take a test image of a horse, the multiplication of this image with the average image of a horse will give a rather big value, and for the other classes, a small value. And that is an intuitive idea on how to get these weights. That's it for this session. Thank you for listening.